Hello everyone, welcome to my channel Learn Maths and ICSE with Trisha. So today we are going to start with the chapter sound from class 10 physics. So without wasting any second, let's get started. Okay, one more thing is that these are my handwritten notes, and these notes are combining few books, and those books had really good portions, so I have assembled it into one specific note, and this is this. So now what you can do is either you can copy down or you can take a screenshot and take a printout of it. Okay, now let's start. So now first topic is reflection of sound waves and echo. So before starting we have to know what is a sound wave. Okay, a sound wave is one when a body, it is vibrating and reaching us through these vibrations of particles through the surrounding medium. So when I am speaking to you all, so it is actually hitting a medium and it is reflecting back to you. Okay, and this is called sound or sound wave. Okay, and one more thing is that sound requires a medium for its propagation. So without a medium it won't be propagated. So one more thing is that now you can also hear the surrounding sounds as well. When I am recording this video, other sounds are also very clear. So what is it doing? It's actually hitting each and every medium and it is coming or reciprocating back to us all. Now another thing, when a vibration reaches to our eardrum, a sound is heard. We all know that. Now again, for our ears, we hear only limited range of frequencies. Okay, that is 20 hertz to 20,000 hertz. That is known as audible range of frequency. Again, sound of frequency above 20 hertz is called ultrasonic, below is called infrasonic, and both these two are inaudible to humans because we cannot hear to that level of frequencies. Now again, they also require a medium and same speed of the audible sound. Now let us get acquainted with few more terms related to sound. That is amplitude denoted by A, time period by capital T, and frequency as F. Now what is amplitude? Amplitude is like a wave that passes through the medium. The maximum displacement of the particle of the medium on either side of its mean position is called amplitude of wave. So you can see this graph. Okay, this is known as A and this is one time period, and these are called the amplitudes. Okay, and this line is known as equilibrium. Now time period. What is time period? Time period is like the time taken by the particle of the medium to complete its vibration is called the time period of wave. So supposing it is going from here to here. Okay, so that it is the time taken by the particle of the medium, okay, to complete one vibration. Okay, this is called time period of wave. Now it is denoted as T and SI unit is seconds. Frequency, the number of vibration made by the particle of the medium in 1 second is called frequency. So number of vibration made in 1 second is called frequency. Okay, it is the same number of waves passing through the point in 1 second. So it is also denoted as F is equal to 1 by T. Okay, now let us get acquainted with more two terms related with sound. First is wavelength and second one is wave velocity. Wavelength is denoted by lambda. What is wavelength? It is the distance traveled by the wave in one time period of vibration of the particle of the medium is called wavelength. Okay, there are two types of graph. First, this kind of graph is known as transverse wave, and this kind of graph is known as longitudinal wave. Transverse graph has C, this is the maximum point, and below it is T, this is the maximum point. The maximum point above is called crest and below it is known as trough. And this particular distance between them, from this particular point, this point to this point, is known as lambda. That is the distance traveled by the wave in one time period. For longitudinal wave, the wave is more compressed form, like a spring. Okay, this C is known as compression and R is known as rarefaction. Okay, now this complete compression to rarefaction is known as lambda. Again, for wave velocity, it is also denoted by lambda, that is the wavelength, the distance travelled by the wave in 1 second is called wave velocity or wave speed. How it is related? V is equal to F lambda. Okay. So now we are going to find the relation between wavelength, wave velocity and frequency. One more thing is that there I have made a little bit error, that is wave velocity I have by mistakenly written as lambda. So you can just correct that and write it as V. Okay. Now we can from the definition of wavelength, we know wavelength lambda is distance travelled by the wave in one time period. Okay, we know that. So from it we can say velocity into time period. So we can say that is lambda is equal to Vt. V is the wave velocity and T is the time period. We also know one more thing, that is time period is 1 by F, that is 1 by frequency. So we are just going to substitute the value of T here and put 1 by F. So what it becomes is V into 1 by F is equal to lambda. So V is equal to now F lambda. So we get the relation between wavelength, wave velocity and frequency. So we can say wave velocity, frequency into wavelength, and frequency or the time period depends on vibrating source producing sound. Velocity of wave and wavelength depends on properties of the medium in which wave travels. Now, transfer of energy by waves is through the vibrations of the medium particles about their mean position. So when medium particles vibrate, there is a change of kinetic energy to potential energy or vice versa. Okay, this is one point you have to know. Now we are coming down to types of waves. So there are two types of waves, mechanical waves and non-mechanical waves. So first, what is mechanical waves? These waves require a medium for their propagation. So whichever sound that is requiring a medium to propagate is called mechanical waves. Example, sound waves travels through air to reach our ears. Ocean waves moves through water to reach the shore. Again, non-mechanical waves, these waves do not require any medium for their propagation. Examples, X-rays, UV rays, infrared, microwaves. Okay, these are all kinds of waves that don't require any medium, so that those are non-mechanical, and which requires a medium, it is known as mechanical. Again, mechanical waves are of two kinds. First is longitudinal wave and second is transverse waves. So we have already found these waves in the previous portions where I have also explained seeing the diagram. So now let us know in detail what it is. So for longitudinal waves, if the vibration of the medium particles are along the direction of the propagation, so wherever the propagation is and the medium particles is also in the same length of the wave, thus forming compression and rarefactions in the medium, the wave is called longitudinal wave. Okay, example, sound wave in air, in solid and inside liquid. It can travel in solid, liquids and gases for longitudinal wave. Now, transverse waves are waves where movement of the particles of the medium is perpendicular to the direction of propagation of the wave. So see the diagram. See, this is the particle motion, okay, both sides. Now this is the transverse wave. This is crest and this is trough, and this is the line of zero disturbance. So this is the direction of the wave travel. Okay. Now see, this is the wave of longitudinal waves. Okay. So this is compression and these are rarefactions. Now this is the direction of motion of the particles of the spring along with the direction of motion of the wave. So both are in the same direction. So that is called longitudinal wave. Now one more thing we have to remember here is compression, rarefactions or crest or trough, they appear alternatively. Both cannot appear at the same time. Okay. Now we are stopping till here. I hope you have understood till here. If there is any doubt, do let me know in the comment section. And one more thing is that we are going to go very slow because this channel is being made for students who maybe a little bit average in their studies, or little bit weaker in science. So it is for them, as well as for the students who are remarkably good. Those for them, they can understand it very well and very fast. But for me, I also prefer students, like I teach slow, so that each and every part is very clear to each and every one of you all, whoever is watching. And I hope you liked it. Do learn, as I have just started. Little by little we are going to step and complete the syllabus, and I'm focusing mainly on the ICSE portions. So, and somewhere or the other we will be following up with some portions in the book that is there in extra, because as you all have bought the book, so you have to just little bit go through some portions I didn't write. So those are best. I'll pick the book and I'll show you what it is. Till here we stop, and do share, like and subscribe, and thank you so much for watching and learn till this much, so that when we continue there will be no issues that you will be facing. Okay, thank you so much for watching.